Hello and welcome to Studying with Chris, where I try my best to explain topics to help both you and me understand concepts. Today we'll be going over completing the square. Now, last video I talked about how to factor down polynomials and quadratic equations. This is a different way to solve quadratic equations um, that may not have integer answers. So in quadratic equations, there's usually three commonly used ways to solve them. First one is factored form that we did last time, and most of the time, if you want to solve for factored form, your answer will need to be an integer. So for instance, plus or minus 1. Now for completing the square, most of the time this is done when you can't factor it down. So if you realize that you can't do product sum to factor down your quadratic equation, you need to use complete the square in order to solve it. And most of the time when you need to use complete the square, your answers are in um, roots or fractions, so they're not integer answers. And quadratic formula is actually essentially just completing the square, but it's a formula that's derived from completing the square. So at the end of this video, I'll show you how to derive the quadratic formula by using complete the square. So to begin solving, we need to isolate our variable terms and our constant terms. So these two here are our variable terms, since they include our variable of x, and this is our constant term of -10. In order to solve by completing the square, we almost have to turn it into a perfect square trinomial. So how does that look like? We know that usually the constant term in a perfect square trinomial follows this pattern, such that c, I'll just say c prime, or c prime is equal to b over 2 squared. Now you can see this in most cases where, say, x squared plus 2x plus 1, where the c term here, since this is a perfect square trinomial, is b over 2 squared, which is just 1 squared, which is like that. And in cases such as x squared plus 4x plus 4, where the c term is b over 2, which becomes 2 squared, which is 4. So we know that in most cases, this constant term in a perfect square trinomial follows the pattern of b over 2 squared. We can write out our perfect square trinomial such that it becomes x squared minus 3x, and since our b term is -3, we can write this as -3 over 2 squared. Now -3 over 2 squared will just become 9 over 4, so I can say plus 9 over 4. Now since I added 9 over 4, I have to retain the value of 0, which means when I add 9 over 4, I also have to subtract 9 over 4. And then I also have this minus 10 here, so I'll bring it over here. And this all keeps the value of 0. Now over here we can see we have a perfect square trinomial, and over here we can see we have some constant values. So how are we going to solve this? As we can see here we have x squared minus 3x plus 9 over 4, so let's factor that down. Now just a reminder, if you want to factor it down, it's x, and then whatever the sign of the middle term is, so if it's plus, it's a plus, if it's minus, it's subtraction. So we'll do minus here, minus, and then the square root of whatever the c value is. So in this case, square root of 9 over 4 is just 3 over 2. So we write x minus 3 over 2 squared. Over here we have some constant values, so we have minus 9 over 4. Now I'm going to change the denominator of this minus 10, so I'm going to turn this into minus 40 over 4. And this becomes x minus 3 over 2 squared minus 49 over 4. Awesome. how do we simplify this even further? So I'm going to add 49 over 4 to the other side. So we have x minus 3 over 2 squared equals to 49 over 4. Now we have a square here, so to isolate for x, we're going to square root. And then when we square root a fraction, it's the same as square root of 49 over square root of 4. So this is going to simply give me plus or minus 7 over 2. Now the reason I say plus or minus is because we're not in the context of radicals anymore. So when we have a square root, we can have both a positive or a negative square root. Now this is going to equal to x minus 3 over 2. So I'll simplify this just to make it cleaner to do x minus 3 over 2 is equal to plus or minus 7 over 2. Now as you can see here, I also have negative 3 over 2, so I'm going to add that to the other side, and we will have x is equal to 3 plus or minus 7 over 2. Now in this case, we can simplify this even further to find its roots, where if it's 3 plus 7 over 2, that gives us x equals to 5. And if it's 3 minus 7 over 2, that gives us negative 2. So these would be our solutions. And I mentioned before that this can also be done by using factored form, so I'll show you that really quickly. So if I had x squared minus 3x minus 10, I can do product sum, so 1 times negative 10. Negative 10 has the factors of 2 and negative 5. So we can write this as x plus 2 and x minus 5, such that the solutions are, if this is equal to 0, x is equal to minus 2, or x is equal to 5. So as you can see here, the answers are still the same, since this can be done through factored form. Now in the next example, we'll try it in the event that you will get a decimal answer. Now here we'll try one where the solutions are not integers. So in this case, we can't factor it down because we can see if we do 1 times 1, there's no factors of 1 that will give us a sum of negative 3. So we have to use complete the square. Now if you'd like to try it on your own and try to see what you can do, go for it. Otherwise, I'll go. So in this case, we can see that our coefficient of x squared is still 1, so we don't really need to do any dividing yet. We'll assume this is equal to 0. So let's start. So once again, I'll separate these, the variable terms and the constant terms, and I'll try to make a perfect square here. So I know that c prime will have to equal to b over 2 squared. So in this case, I'll say x squared minus 3x plus negative 3 over 2 squared, so that's same as last time, 9 over 4. And then I want to retain the value of 0, so I'll make this minus 9 over 4 as well. And plus 1 is equal to 0. Now, as you can see, we have a perfect square here. So we can say that this becomes x minus 3 over 2, which is the same as last time, squared, since this is a perfect square trinomial, minus 9 over 4 plus 1 is equal to 0. So I'll further simplify this into x minus 3 over 2 squared, and I'll turn 1 into 4 over 4, so it becomes 9 over 4 plus 4 over 4. Now this becomes, I'll just simplify it even further, this becomes minus 5 over 4. So minus 5 over 4 is equal to 0. And then we'll move this to the other side. So we add 5 over 4 to the other side. So we have x minus 3 over 2 squared equals to 5 over 4. Now we'll square root. Now this becomes x minus 3 over 2. And on the other side, it becomes plus or minus 5. And since this just simplifies to 2 over 2. Now we can add 3 over 2 to the other side. So we do square root of 5 over 4, and this becomes x minus 3 over 2. And this simplifies to plus or minus, we're going to keep it as an exact value, so root 5 over 2. Now we can add 3 over 2 to the other side, so plus 3 over 2, plus 3 over 2. So we can write x as equal to 3 plus or minus root 5 over 2. And this is it as the exact value. We could simplify it, but most of the time it will ask you for your answer in simplest form. So this is what x would equal. Now, for the next example, let's try it in the case where we can't use negative. So in this case where we have a coefficient of x squared that isn't equal to 1, let's try to solve it. So I'm going to make the coefficient equal to 1, so I'll divide the entire equation by 3. If I divide by 3 here, but I don't need to worry because it still keeps at 0. So this becomes x squared minus 4 over 3, minus 2 over 3 is equal to 0. Now, how do we go from here? Well, it's basically the same steps, but they're in fractions, so it might be a little harder. So it's the same case, though, where our c term will be equal to b over 2 squared. So this is just simply equal to negative 4 over 3 over 2 squared. Now this isn't too bad, so this will simplify to negative 4 over 6 squared, which we can further simplify into 2 over 3 squared, which becomes 4 over 9. So this becomes 4 over 9. Now, let's isolate our terms. So we have x squared minus 4 over 3x plus 4 over 9 minus 4 over 9, just to keep our value 0, and minus 2 over 3. Now, we know this is all still equal to 0, and we have these set of terms. So let's simplify it here. So we'll have x, and the middle term sign is negative, so we'll do minus, and then square root of our c value is 2 over 3, so x minus 2 over 3. And we have this side, so I'm going to simplify our fractions here, so it becomes minus 4 over 9 minus 6 over 9, and that just becomes minus 10 over 9 is equal to 0. Squared. Now, let's add 10 over 9 to the other side, so we have x minus 2 over 3 is equal to 10 over 9. Sorry, you have to remember the squared part too. And then let's square this square root. So we'll end up having x minus 2 over 3 is equal to plus or minus square root of 10 over 3. we add 2 over 3 to both sides, and we'll have x is equal to 2 plus or minus root 10 over 3, and that will be our final answer. Alright, awesome. So after this, I'll show you how to derive the quadratic formula using complete the square. So this is how you derive the quadratic formula. So right here we have a standard equation for a quadratic equation, and the quadratic formula is basically a way that tells you what the value of x can be depending on your values of a, b, or c. So we'll just derive it like a complete the square equation, but we'll just think of everything as variables. So in this case, we have a as our coefficient and we want as 1s. So we'll divide all terms by a, and we'll divide 0 by a as well. Now this leaves us with x squared plus b over a x plus c over a, so this is just still equal to 0, is equal to 0. Now we need to do what we did before with the value of c, which is equal to b over 2 squared. Now since in this case b over 2 is equal to b over a, so we can write this as b over a over 2 squared. Now this a will just go into the denominator here, so we can write this as b over 2a squared, which we can finally write as b squared over 4a squared. Now we'll just write this down here as is. So we'll have x squared plus b over ax plus b squared over 4a squared minus b squared over 4a squared plus c over a is equal to 0. Now this looks really complicated, but it'll start making sense really soon, pretty quickly. So, like we did before, this is our perfect square trinomial, so we'll simplify it down. Now this just becomes x, and since it's plus, say plus, and then the square root of this, which is b over 2a squared. Now on the other side here, we have minus b squared over 4a squared. Now I'll make the denominator the same, and in order to do so, I need to multiply c by 4a. So I'll have minus b squared over 4a squared, and over here I'll have plus 4ac over 4a squared. Now if we move this over to the other side, we'll have x plus b over 2a squared on this side. I add b squared over 4a squared, and I subtract 4ac over 4a squared, so I'll have b squared minus 4ac over 4a squared. Now I'll square root both sides, and this becomes x plus b over 2a. This side becomes plus or minus square root of b squared minus 4ac over, and since this is a perfect square, this becomes 2a. Now since both of these denominators are the same, I'll minus b over 2a minus b over 2a, and then at the very end, I'll have x is equal to negative b plus or minus root b squared minus 4ac over 2a. That is your quadratic formula. Now, this equation is incredibly helpful since it tells you the values of x by if you have a, b, or c. And using this, it can help you solve pretty much all quadratic equations in that format. So it's incredibly helpful to help you find the quick solutions, and you can find many theories and try to find how many solutions there that exist using this equation. And it's helpful. However, knowing how to derive it and knowing how to complete the square is also helpful for many future equations, such as vertex form or needing to solve it algebraically where you can't just plug and go. So knowing how to complete the square is incredibly helpful. However, if you're not required to and you need to solve something quickly, using quadratic formula that we derived here can help you solve all of that. Otherwise, regardless, I think that's all for me today. Thank you for joining in. And if you have any questions, let me know. Otherwise, thank you for studying with me.